Would it surprise you that we are traveling around our star, which is called the Sun, at about 67, 65, let's round it, 65,000 miles per hour? So in orbit going around our Sun, we are traveling at 65,000 miles per hour. Can't feel it, can you? But we're not done yet. Would it surprise you to know that, let me extend the page here, that our little star is part of a very big galaxy called the Milky Way galaxy? And we're about 3/4 out. So our little star is right about here. Okay, and would it surprise you to know that that we are spinning around the whole galaxy at about, I think it's 100,000 miles per hour. I'll have to check that. I think it's more than that, but in any case, we're spinning around that galaxy even faster. So we are really moving very fast, but we cannot feel it, is the important point. Okay, we cannot feel a change. We can only feel a change in motion, but not a constant motion, which is what a velocity or a speed is. A velocity or speed is a velocity is a change in position, a change in distance. I'm going to say distance over a change in time. I'm just going to put time here this time. Over time. Well, a speed. The velocity is a vector, though. Okay, so it has a direction. We are going in a particular direction. But the important point here is that velocity or speed is a change in distance over change in time. Remember the first picture up on top. I changed my position. I changed my distance. I was here, and I went over to here. I was here, and I moved over to that point. I changed my position. I changed my distance, and I did it over a certain amount of time. Okay, so we know what a velocity and scalar is. Now, I'm a little concerned that most of you know from your old school, from your 8th grade, what this triangle means. I just want to pause a moment here and make sure that we all are on the same page. Okay, let's see. Let's put in a triangle. Okay, there it is. Now, a triangle is called delta. That's what it's called when you see it. But what it really is for us in science right now, when we see this, we know it means change. This equals change. And it can be a change in anything. Okay, a change in distance. If I walk a certain distance, let's say um, let's do it even better. Let's do it a better way. Look at your second clock, seconds on the clock, like we did in class. That's what we did in class. We looked at a clock, and I'm going to recreate that. Here's our clock. And I said, when you look at our clock, I wanted just to watch the second hands and pick any point on that second hand. Okay? So let's see. We watched that second hand go around, and we said, okay, here it is, right there. It was at the 10. Okay? And then from there, we said it ended up, when I said stop, it ended up down at the 5. Okay, our second hand. So let's see what that meant in terms of change. We started off at a position we called our T start. And that was equal to 10 seconds after 12. So I'm just going to put down 10 seconds over here. Okay? It was after the 12. The 12 is right here, of course. And then I said stop. And we stopped at about what a place we'll call T stop. And that was at 25 seconds past the 12. Now, what's a change? A change, in this case of time, is equal to T final minus T start or T initial. Now, I'm giving you a new word over here. Start is the same as initial. And I'm saying it this way because the books always seem to use TI for initial starting point. Okay? So you're just going to have to memorize that. For the time being, I'm just going to put a little S over here so we know that's the same as the start. And now we simply put in what we had. We had a final time that was 25 seconds. And we had minus a starting time or initial time of 10 seconds, which meant our change in time, it's a triangle, believe it or not, that's my triangle, a change in time was equal to 15 seconds. I told you to go back and count. Sure enough, we counted. It was 5, 10, 5 here, 10 there, and 15 seconds. So we knew what our change in time was. It was 15 seconds. Let me make sure we put an SEC over here so you don't think it's 255 something. Okay, that was our change in time. 15 seconds. Now I said a change was good for almost anything we wanted. And I told you the story. I'll give you one more example of a change in, let's pick something else. How about a change in donuts? Remember I said this? A change in donuts. And I told you the story how I had gone to Dunkin' Donuts because Mrs. C told me we had company coming over and I had to pick up some donuts. Now, a change in donuts is, I'm going to put this as DO for donuts, final, little f down here, minus DO initial. And again, initial means start. Okay? Okay, and I told you the story how I had gone to the store and I bought 10. So my D starting off with, my D initial was, 12 donuts. Not 10, 12. 12 DOs. Okay. But on the way, a robber came up. At least this is what I told Mrs. C. And she believed me, so I didn't get in trouble. And took some of my donuts, so that all I had left in my final, when I got home, was 8 donuts. Good thing she believed me. Okay? Now let's put that in and see what our change was. Okay, I started off with 12. That's my donut's initial. And I ended up with 8 donuts. Okay, 8 minus 12 is what? Well, it looks like minus 4 to me. Minus 4 donuts. And sure enough, that's exactly what happened. My change from what I started off with to what I ended up with was minus 4 donuts. I lost 4 donuts. And Mrs. C believed me, so I did not get in trouble. I wiped off the powdered sugar off my face, so she didn't know. And that's good. Don't tell her. If you see her at a football game or something, please don't tell her. I'll be in trouble again. Okay, so that's how we know what a delta is. It is a change of anything. Donuts, time, miles, anything at all is a final minus the initial.